supporting English language learners in STEM subjects towards a way of adjusting curricula to promote inclusion. Thank you so much.
Thank you, Stephanie, and thank you, everyone. Good morning, everyone. We're very happy to be here presenting today. So I am Dania Wattar. I'm a research associate and lecturer at OISE, and May is along with me.
Hello, everyone. My name is Naji. I am a doctoral candidate in educational leadership and policy at OISE. I am also a research assistant with the ESCAPE projects. My own research focuses on the role of student soft skills in shaping their transition to post-secondary education.
And we have Dr. Emmanuelle Pichon, who is an assistant prof and director of GRIFO, and she is a co-principal investigator on the project. Along, we are honored to have Dr. Jim Cummins as well as a principal investigator on the project we'll discuss about.
So this is an overview of what we will be covering today. We will start with some background information, talk about mobility in education, our research questions and methods, and we will share some of our results with you. And finally, talk about implications and next steps. Moving on to the research questions, the overarching research question is, how do we welcome multilingual students, taking into account their academic achievement? For our presentation today, we have two sub-questions, which are, what types of knowledge are taught to Syrian students prior to joining Canadian schools, and what tools can support the students in learning mathematics and science? Dania will now give you an overview of the ESCAPE projects.
Thank you, May. So the work we are doing right now is related to 3 funded projects. We call them all as ESCAPE projects. Feel free to grab your phone to scan the QR code to go to our website. We'll put also the link to our website in a few minutes in the chat for your information, so you can find out more about our projects and our research. One important part in our project is a multilingual multimedia technology that is called Binogi. And again, if you would like to access the technology, please grab your phone, take a picture, go to the camera and scan the code to go to Binogi. And what's really unique about Binogi is that it offers educational video quizzes for students in different languages. So you see over here, I can choose what language to listen to, whether English, Dari, German, French, Arabic, etc. And more languages are being added, and what subtitle I would like to use. So for here, you could see in the video, if I play a couple of seconds, that, for example, you probably
so we'll skip this.
Can hear in English
By definition,
and read
every
in Arabic.
even integer
I may
is divisible
decide
by
to
2.
change to Dari or German.
Even integers end with 0, 2, 4, 6, and 8.
Unfortunately, we don't have a lot of time to go through a full video, but it is a very cool application, and we'll talk about how this is supporting multilingual learner and how different videos and quizzes are available in different languages. So we're going to go back a little bit to, Ontario recent Ontario math curriculum and, curriculum document, policy documents, where we see there's an emphasis on students' various linguistic identities, using rare linguistic repertoires in a fluent way to support learning math and science. We look about the importance of technology to access mathematical terminology and, different ways of solving problems in students' first languages. So if you look at the curriculum document, they talk about the importance of prior learning experiences, background knowledge in math, and the use of technology to access mathematical concepts. We all enjoy reading policy documents and knowing what we need to do, but how do we do it? As teachers, what do they know? And in this research, we really wanted to see how we can actually, do this. How does how can we reflect those policies in action? And we recently published a chapter. If you are interested, the reference is there at the bottom. It's still in press, but should be available soon. The mobility of Syrian students and continuity of math education, where we discussed some of the research, which we will give you some highlights today. on. And I know you've been sitting since 11 and trying to, listen really nicely. So I thought we'll share with you a little brain teaser, which will, hopefully help refresh your math memory, but also allow you to think about some of the issues that we will be discussing today. So let's try this, and then we will come back to this at the end of the presentation. So if you have a pencil and paper and you'd like to do some, brain teasers or some math in the morning with some language twist, considering this is a language conference, please feel free to go this. And so the question is, solve the following equation. And I have over here indicating, for those of you who know about the Arabic language, usually text is read from right to left. So the equation says sin ناقص 5 يساوي 10. And of course, we understand that you will need clues. Not all of you will understand Arabic. So sin is a variable, so kind of like X. ناقص is a negative sign. 5, you can look over here, it's a number 5, and then 10 is 10. So feel free to write that, and then whenever you have the answer, you can pop your answer in the chat. It's okay to put the answer in English, and we will revisit this at the end. We'll tell you the actual correct answer, but we'll also discuss implications. So what we did is that we really wanted to understand, with the high influx of Syrian refugees coming to Canada, we wanted to understand these students' experiences and knowledges of math, and then later of science. And one of the things that we want to understand is that students, what did they learn before? We talk about understanding students' prior knowledges and experiences. And we thought one way that would really help us do that is by looking at the Syrian curriculum and understand how it compares to the Ontario curriculum. So we analyzed grade 4 to text, we looked at content, we looked at linguistic and cultural issues, and looked at the similarities and differences between the Syrian math textbooks and the Ontario curriculum expectations. We also did the same for science, and May will tell us a little more about this.
Yeah, so in order to gain a better understanding of students' previous knowledge in science, we also developed a comparative curriculum map that compares the Ontario and science curricula. We focus particularly on grades 6 to 9, since the Binogi platform focuses on grades 6 to 9 as well. We wanted to identify differences and similarities, and which could be very useful to teachers and would allow them to build on students' prior knowledge or provide support if students' background knowledge is lacking. This comparison could also be very useful to parents to better support their children and be more engaged in the learning process. We focused in our research also on comparing key concepts in both curricula. We identified overlapping concepts and compared those to concepts that are mentioned in the Binogi lessons. For our comparative mapping, we used the Ontario curriculum, grades 1 to 8, Science and Technology document, which was published by the Ministry of Education in 2007. And for the Syrian curriculum, we used the Syrian science textbooks published by the Ministry of Education in Syria for the academic year 2019-2020. Dania will share now some of the results of the math comparative mapping.
Thank you, May. So as you may be familiar, if you are familiar with the Ontario curriculum of math, you may have seen these tables that kind of shows how different concepts such as multiplication and division are taught throughout the grade. So each grade, a concept builds on students' prior knowledge of previous grades and so on. So say, a student is joining schools in Ontario in grade 7, teachers will usually assess students to see if they have the prior knowledge that, we expect students to have attained in grades 1 to 5. So to kind of have a comparison, what we went to the Assyrian curriculum and we created similar tables to see, for example, you see here operations, and we wanted to see also the progress in what is taught in each grade. We really wanted to see whether things, are taught differently or similarly to Canadian curriculum. Are they taught the same grades? And what we found is there are some differences, of course. There are some topics, interestingly, that are introduced in Syria earlier than in Ontario. And there are some topics that are introduced, with different approaches or different varying levels of depth, such as data management, for example, where Syria kind of have brief theoretical introduction, where the Canadian Ontario curriculum has more like an experiential component. So we wanted to put our results on our pilot website, which we're working on. And again, I'll put all the links in the chat once we're done. And you could see here the process for how we went through the curriculum mapping. We tried to do the mapping first in Arabic. Arabic, and then translated it to English to make it accessible to teachers. What we noticed as we were translating the concept is that it was not simple. A lot of the concepts are academic concepts and needed more work through it. As a result, we felt that it would be very beneficial to actually create a glossary of terms that supports teachers and students. So as students get into Ontarian schools, they can actually make connections between what they have learned in previous years and what they are learning in Canada. So we created the simple glossary where you have the term in Arabic, term in English, and definition of both course terms. And we try to kind of get terms from the glossary of the Ontario curriculum, as well as any additional terms that we came across in the mapping. And we kind of did a similar process with science, building on the work that we've done in math. May will elaborate more on that.
Okay, so building on our work with the math, our results from the comparative mapping of math and science curricula were very comparable. They showed significant differences in curricula between the two continents. For example, while the Ontario Syrian curriculum is presented more in the form of objectives and guidelines and is organized in strands, which usually run across all of the year groups, the Syrian curriculum is more textbook-based and presented in the form of specific topics that actually might differ from one grade to another. Another difference is that there are many more topics covered in the Syrian curriculum compared to the Ontario curriculum. And actually starting in grade 7, the Syrian science curriculum is organized first by subjects and then by specific topics. The comparable results for math and science suggest that the teaching in both countries is in general very similar across topics. However, we thought that since we were comparing guidelines from Ontario to textbooks in Syria, there may be a loss of content between the ministry document and the teaching program in Ontario. So to further explore the differences in content, we are currently working on comparing the Syrian science textbooks with the textbooks used in Ontario. So far, we have found significant differences both in topics and number of chapters covered in each grade. For example, for grade 7 in Ontario, the textbook has 12 chapters, while in Syria, there are 39 different chapters. Our initial results also suggest differences in the pedagogical approaches. For example, the Ontario curriculum, the Ontario science curriculum focuses on the acquisition of 4 categories of scientific knowledge and skills with very clear criteria for each. These are knowledge and understanding, thinking and investigation, communication and application. While in the Syrian curriculum, such categories of scientific knowledge and skills are not explicitly identified, and there's more focus on the body of knowledge and less on the acquisition of skills. We also found that more concepts are introduced in each grade in Syria than in Ontario. Additionally, one of the results of the research that we have done is that the Binogi video represents a fairer reflection of the Syrian curriculum than of the Ontario curriculum. And the reason is probably that the Syrian curriculum is very similar to European curricula, which is in general are more dense in terms of concepts introduced than the Canadian curriculum. Moving on to this slide, we also wanted to compare how scientific concepts are defined in both curricula and also in Binogi videos. So we developed bilingual science glossaries in which concepts are explained both in the school language and the student's native language, Arabic in this case. One of these glossaries is a general glossary in which we started with scientific terms in the Ontario curriculum glossary of terms. We included also concepts that are mentioned in the Binogi lessons linked to the Ontario science curriculum. For each concept in the glossary, we added the translation in Arabic and its definition in Arabic as defined in the Syrian textbooks. Another glossary that we developed is a bi-topic glossary. We also started here from the Ontario science curriculum. However, focusing on particular strands, we also explored Binogi lessons linked to each strand, and we listed the concepts that are linked to each lesson. And for each of these concepts, we wanted to explore both formal and informal definitions. In this framework, concepts' formal definitions included how concepts are defined in the Ontario curriculum, Binogi concept library, and the Syrian curriculum, while the informal ones included spoken definitions that we have taken from the narrated Binogi videos, both in English and Arabic, and also included examples or illustrations. Moving on to the next slide, the first table is a snapshot of the general glossary. This glossary is organized in alphabetical order and also by color. Light green represents concepts from the Ontario curriculum, while the dark green represents concepts from the Binogi lessons. It includes 284 concepts from the Ontario curriculum, 84 concepts from the Binogi lessons, with 30 concepts appearing in both sources. The second table is a snapshot of the bi-topic glossary. Again, it's organized by strands, then by lessons and the concepts. Dania, over to you.
Thank you. So if you were able to get a chance to look at the brain teaser, hopefully you got a feeling about what this is about. Okay, thank you. And you know, some of the things that Syrian students or students who learn you know, navigate is kind of switching between writing from right to left, using different symbols, different numerals. And here are some kind of tips and tricks that we share with teachers when we talk about the issue and the importance of understanding students, the languages they use, and how that affects their learning of mathematics. So we're gonna end with implications and next steps. Go ahead, May.
Yeah, so in terms of implications and next steps, these include further exploration of the differences in the math and science curricula between Ontario and Syria, and also extension to more languages, for example, Farsi, developing multilingual glossary resources and exploring how to pedagogize these resources. For example, the multilingual resources that we are developing can be used for dynamic, diagnostic, or formative assessments. They could be shared with school stakeholders, assessors, teachers, or policymakers, and could also be used as resources for students to allow more agency in learning. And that is what we will be testing with Binogi next year. Our next steps also include working on the Binogi interface to test its utility with student learning and to link relevant concepts to Binogi videos and quizzes. These concepts will be listed along with simple short descriptions under each video, with the option for students to view the corresponding concept in their first language. We would also like to allow for cultural input from students, families, and professionals. For example, how students would conceptualize different concepts in their own language or the school language, how they would provide an illustration or provide exemplification of these concepts. And finally, work with teachers next year to develop pedagogical material and explore how teachers in classrooms would use, adapt, transform, or resist these resources.
And of course, we would like to recognize and thank every team member in one or more of the three projects. Without them, we wouldn't be able to be here, and we really appreciate their support and contribution to the project. Please feel free to reach out to us, whether it's by email or Twitter, and remember to go to our website, escapeprojects.ca. Thank you so much.
Thank you.